Okay, so the crossover rule. What is the crossover rule for? The crossover rule is for working out the formulae for ionic compounds. And what we're going to do is we're going to have a quick explanation of why, and then we're going to show a whole load of examples. So, ionic compounds. Ionic compounds, as hopefully you know, are ones that are made up with metals and with non-metals. So, why does this work? Metals have a tendency to lose electrons and form positive ions known as cations, which one can remember are the positive ones because the T looks like a plus. They do so because it is energetically favourable for them to do so. Non-metals do the opposite, as they are the opposite effectively of metals. They have the tendency to gain electrons and form negative ions, which are called anions, which you can break down as such: a negative ion, anion. We will look at exactly how this works, where the electrons go from and go to, and in what ratio, in a later video on ionic bonding. But for now, we're just trying to work out the formulae. So, if we know metals form positive ions, we can see that the metals in group 1 are going to form ions with a +1 charge because they have 1 electron to lose from their outer shell. In group 2, they will form +2 ions. All of these babies in the middle are transition metals, and we will deal with them later. The metals in group 3 would therefore have 3 outer shell electrons and form +3 ions. I'm going to cross out hydrogen and I'm going to cross out boron because they are non-metals and they are atypical. Hydrogen does form +1 ions in certain circumstances, but we're not really going to deal with hydrogen ions in this context. Okay, so the non-metals. Well, firstly, we can almost cross out or get rid of Group 8. Group 8 are the noble gases. It is not energetically favourable for them to gain or lose electrons, so they don't get involved in bonding at all. If we look at group 7, they all have 7 outer shell electrons. They will all gain 1 electron. Gaining 1 electron will take them to a -1 ion. Group 6 all have 6 outer shell electrons, which means they will gain 2 outer shell electrons, which will take them to a -2 ion. And similarly for group 5, 6, 7, 8, they will gain 3 electrons to make them into -3 ions. There we go, 1, 2, 3. This group in the middle, group 4, as you can see, there are some metals in there, some non-metals in there, and to be frank, it is a little bit confusing as to which way they're going to go, and we don't really deal with them at GCSE, so you don't need to worry about them. Okay, so let's pick some combinations of metals and non-metals to form compounds and see where we go. Well, where should we start with? Let's start with lithium on this side, and let's do lithium oxide. Lithium oxide, the compound with lithium ions and oxide ions in it. Okay, so lithium, I'm going to write down the symbol. Oxygen, I'm going to write down just the symbol. Don't worry about whether things are diatomic or not. We are just writing down the symbols to begin with. Now we're going to write in the charges. What's the charge on the lithium ion? Well, the lithium ion is going to be +1 because the lithium ion here is in group 1. It says +1 at the top. Okay. Why is that? because it has lost one electron. But for now, we can just look at it and go, it's +1, let's go with it. Oxide. Oxide, what does that have above it? It has -2. Cool. So what we're going to do is we're going to draw a line underneath. Always do this. It doesn't seem very important at this point, but it will come to importance in a later video using something called compound ions. But for now, we'll just draw that line underneath. We take the magnitude, the size of the charge down. So the +1 just is a 1. The -2 is just a 2. This is called the crossover rule, so we cross the numbers over. So the 2 crosses over onto the left. The 1 from the left crosses over onto the right. That 2 on the left tells me I have 2 lots of the lithium. Li2. The 1 tells me I have 1 lot of the oxygen, O1. Except we never write 1s in formulae, so the formula is Li2O. Let's do another one. What should we pick? Let's pick calcium, and let's pick calcium chloride. Okay, so calcium, Ca, chloride, Cl. Let's put the charges in. Calcium is group 2, so it's going to be +2. Chloride, group 7, so it's going to be -1. Draw our line underneath. Take down the magnitude, so just the size of the charges. The 2 comes down underneath calcium. The 1 comes down underneath chlorine. So this 1 has gone down there, and this 2 has gone down there. Okay, let's get rid of those because it'll be confusing later. What do we do? Well, it's a crossover rule. So let's cross them over. Cross them over. The 1 comes down to the left. The 2 crosses over onto the right, which means we have Ca1, Cl2. But of course, and this is the last time I'm going to draw these in like that, we don't write 1s in, so that disappears. CaCl2. Let's do a couple more because I think you're probably getting the hang of this by now. Right, let's do aluminium. Let's do aluminium bromide. Why not? Aluminium bromide. Aluminium, Al, bromide, B are just the symbols. Don't worry about diatomics or anything. This is just symbols that are going in. What are the charges? Al +3, Br -1. Draw your line underneath. Write your size of your charges underneath. Cross them over. It is always worth doing this in full, writing everything in. Otherwise, you'll end up making silly mistakes and getting confused and getting it wrong, which is no good at all, really. So what have we got? Well, we've got 1 lot of the aluminium, Al, 3 lots of the bromide, Br3. Note with all of these formulae, 1, 2, 3, I do not have any charges written in the formulae because they are compounds. The charges all balance out, therefore we don't write them in. We do not put charges in normal formulae. Okay, we do for ions, but these are not ions. They are ionic compounds. They do not have charges on them. We're going to do one more. And this one, there's a little trick to it, so I'm just going to show you this. We're going to do magnesium, and we're going to reuse oxygen. So let's put the yellow in there. We're going to do magnesium oxide. Mg and O, just the symbols as we have done before. Now put in the charges. +2 for magnesium because it's in group 2, -2 for the oxide because it's in group 6. 2, 2, cross them over, 2, 2. So you would be forgiven for thinking that it is going to be Mg2O2, but that is not quite right. What we do, we'll get rid of that. We always give the simplest possible ratio. This is actually something called an empirical formula, which you will come across at some point, but we always give the simplest possible ratio. So this goes from 2 to 2 to 1 to 1. So the formula for magnesium oxide is MgO. So, no charges in the formulae. Always give the simplest ratio. How do you know where the charges what the charges are going to be. You get the charges from the position of the elements on the periodic table, and that's it. Go and practice these for yourselves. Go and get some experience doing these. We'll deal with transition metals and compound ions in a later video.